All right, awesome. Okay, so the two things we will do, and you can work ahead of me. I don't mind at all if you want to try to work ahead, because if you want to work ahead of me and listen with one ear, there are a couple questions on the board you could do after it.
Are we gonna have to know the Greek letters?
The theta.
Yeah.
I'm not going to use theta. You will see it when you get to trig. Yeah. Theta is just a Greek symbol that represents a missing angle. I'll just keep it to letters like A, B, and C. All right. And our whole goal is to solve the right triangle. So when I tell you to solve the right triangle, that means just come up with all the missing pieces. So that's example 1. I'm going to have you write down both examples in case I get some people that are super antsy and want to work ahead. All right. So to solve a right triangle means you have to have all 3 angles measured and all 3 segments measured or marked. So this first example with the A, B, and C, that's where I'll start. If you work ahead of me, you need to pause and listen as I get to the answers to make sure you have the right answers as well. All right, so here's the first one. You cannot do trig from the 90-degree angle. There's no sine, cosine, or tangent from this angle C. Has that been made clear to you? Okay, perfect. So we're either using angles A or B to do all trig functions always. Before we start, take note of what you have. Take inventory of what you're given. Do we have an angle marked for us? Yes or no? Yes. So then we do not need inverse trig. No shift or second anything. Okay, if we have an angle marked, this is all normal trig. All right, so let's start with that. So let's put an X here, a Y, and a Z. So we need to find the value of these 3 little variables to be able to say we're done. Let's find X first because it is by far the easiest thing to find. How do I find the value of X if this measure is 31 degrees and this one's 90? What do I do?
Just subtract 31 by 90.
Good. 90 minus 31. So X is equal to 59 degrees. And I think I went over that in the video that I made for you. You can just subtract it from 90 because if this whole triangle equals 180 and this is already 90 degrees, doesn't it force these two to be 90 degrees as well? All right, so 59 degrees. All right, let's go to Y. We'll just go in alphabetical order. All right. Before I move on, let's go ahead and label the hypotenuse. Where is the hypotenuse? The 14, the Y, or the Z? So the Y is the hypotenuse. So I'm going to use the hypotenuse in my trig ratio. So which 2 trig ratios might I be using? Good. I'll be using either sine or cosine because I want to use the hypotenuse. Perfect. Before I can figure out if it's adjacent or opposite, I need to know where I'm standing. Where should I be placing myself? Do you think I should be at the A or the B? Sure. It doesn't matter. But I'm going to stand at the A. So if I'm here at this letter, and you can circle it instead of highlight it if you prefer, what does that make the 14 be? Is that the opposite or adjacent? And then that makes the Z adjacent then. Okay, so for Y, I'll make Y in green. I'm going to use the hypotenuse side already. I've already decided that. What other side should I use? The 14, the opposite, or the adjacent with the Z? Good. You have to use the opposite, the 14. I already have one unknown. I already have one variable. I cannot have two, and that wouldn't be solvable. So I'm going to use the two in green, which are hypotenuse and opposite. So hypotenuse and opposite is that sine or cosine. Opposite hypotenuse, which one? Sine. Sine. Sine is opposite over hypotenuse. So for y, I'm going to do sine of 31. You always do the measure of the angle from where you stood. Sine of 31 equals opposite over hypotenuse. Do I multiply or divide?
Do you divide?
Good. You divide because the y is in the denominator. So you just switch these around and you do 14 in your calculator. So everybody calculators out. Let's do this together. You're going to just divide what you see. So it's 14 divided by, some of you it's sine 31. For my calculators, it's the other way around. It's 31 sine. 31, the sine of 31 is 0.5150, so you have to hit equals to be able to get the actual value. If you have a calculator that lets you plug in sine first, then do that. 27.2. We good with that? Questions? If you don't ask a question, I don't know if you're struggling. And like I said, I know a lot of you did pretty well, so if I am boring you, hold on, I'll move on to something new eventually. But the value of y is 27.2. I had a teacher in college that was very clear about using approximation symbols whenever you round. So by habit, I do that a lot. So I'm showing it to you now so that explains why I do that. So if you see the approximation symbol, it just means that I've rounded. You can use equal signs if you want. I just wanted to be clear because you'll see that from time to time. All right, there's the value of y. Last one, value of z. I'm going to continue with trig. If you want to, at this point, you could use Pythagorean's theorem, but to me, trig is faster. May not feel like that to you yet, but I want you to get used to it. I want you to see one more. So z, I'm going to make z blue. So I have to use the adjacent side. I'm still going to stand at angle A. And I'm going to go ahead and kind of highlight the 14 in both the blue and the green because I'm going to use that same value for both my x and my y and my z. So I'm looking at the blue now. Is the hypotenuse included in the two blue shaded sides? Yes or no? So the hypotenuse is out of this question altogether, so then it has to be which trig function? Tan. So tan of 31 equals opposite over adjacent. Multiply or divide? Another divide one, so try it out again, see if you can get it correct. So 14 divided by tan of 31 or 31 tan. As a rule of thumb, you can round the side lengths to the tenths and round angles to the full degree because it's miserable to have angles with a tenth marked on it. So angles to the full degree are just fine, and sides to the tenths are also just fine. Anybody get that? Are we good? Preaching to the choir? You got it? No questions? All right. You're going to practice in a minute, so if you are really hesitant about whether or not you've got it, you can prove it to me then. All right, and then one more that has a different type. anybody done with it? I want to see answers quick. Here are the answers. 5.7, 22, and 68. So if you got them right, you can go ahead and do 543, 18, and 19 if you want to. Okay. Let's take a look. So I'm going to label this X, Y, and Z. And I guess I'll call my triangle LMN. Don't know if it really matters, but. Okay, so I need to find the values of X, Y, and Z. If you take inventory of what you have, what you're given, do you have a measure to an angle in this problem? Is there, other than the 90-degree marking, is there an angle value provided? The answer is no, right? We don't have that. So you're going to have to use inverse trig. When you need to find an angle, you're going to have to use inverse trig, and that's just something to kind of keep in mind for the rest of our trig unit. Okay, but before we get into inverse trig, let's do the easier option first. We could do Pythagorean's theorem to find x. I had a lot of people on your quiz misplace the c value. I think you were just going too quickly. Where does the c value have to be? Is it the hypotenuse or the leg? Hypotenuse, yeah. The hypotenuse. So make sure when you do Pythagorean's theorem that you're careful about that, please. So 2.1 squared plus 5.3 squared equals our x squared, or c squared side. All right. So then if you do and you can just do that on your calculator, 2.1 squared 5.3 squared square rooted. What do we end up with? Anybody else get 5.7? Okay. All right, perfect. So x is 5.7. Okay. So then let's go ahead and do y. Okay, so for the value of y, I'm standing at y. So since I'm finding that angle, it's easy to know that's where I'm standing. What sides am I going to use? So if I'm standing there, I've already got the hypotenuse marked. What's the 2.1 marked with? Opposite or adjacent? Again, I'm standing at y. So this will be opposite. And 5.3 is adjacent. Which trig function do I use then for opposite adjacent? Is the hypotenuse included? No. So tangent, good. So tan of y equals 2.1 over 5.3. So 2.1 over 5.3. The way to know that you're using inverse is because now you don't have a variable there. Over here, in these cases, I had 14 over y and 14 over z. So both of those had a variable. Here it doesn't. So 2.1 over 5.3, you can just divide in your calculator and then hit second or shift tan. So try it out, see if you get it right. So 2.1 divided by 5.3. And then if you hit shift or second tan, 21.6. So round it to the nearest degree, so you don't have to deal with decimals. So 22 is our value for angle y. I guess we rounded on that one too, didn't we? All right, and then nice and simple, because it's a degree and it's a triangle, Now that we know 2 out of the 3 angles, super simple to find the final one. So Z is just 90 minus 22. So Z is just 90 minus 22. So my final answer for Z is how much? Good. Nice job. Okay. So that's just a quick review. I am hopeful that some of you felt really good.